Why don't scientists trust atoms? Because they make up everything. Hey there, science fans. Welcome to another exciting journey into the world of technology and innovation. Today, we're going to explore something that has revolutionized the way we live, work, and play. It's a tiny component, but its impact is monumental. Any guesses? That's right, we're talking about transistors. Today, we're diving into the fascinating world of transistors. These little devices are the building blocks of modern electronics. Without them, our gadgets would be bulky, slow, and far less capable. These tiny titans are the unsung heroes of our digital age. They switch electronic signals on and off, allowing us to process information at lightning speeds. Imagine them as the gatekeepers of the digital world, tirelessly working behind the scenes. No computers, smartphones, or even your trusty toaster oven would exist without them. Every electronic device you use daily relies on transistors to function. From the moment you wake up and check your phone to the time you cook dinner, transistors are at work. But before we get into all that, let's rewind back to the days before transistors. Imagine a time when electronics were in their infancy and scientists were grappling with the limitations of the technology available to them. Back then, electronics relied on bulky, inefficient vacuum tubes. These glass tubes were the precursors to transistors, but they had significant drawbacks. They were large, consumed a lot of power, and generated a lot of heat. Imagine light bulbs trying to do the work of tiny switches. That's what it was like. These vacuum tubes were like giant glowing light bulbs that had to be carefully managed to keep electronic devices running. These vacuum tubes were power hungry, slow, and prone to burning out, kind of like a student during finals week. Something had to change. The world needed a more efficient, reliable solution to keep up with the growing demands of technology. The world was waiting for a smaller, faster, more reliable switch. Engineers and scientists were on a quest to find a better solution, one that would pave the way for the future of electronics. Little did they know, a revolution was brewing in a little place called Bell Labs. This was where some of the brightest minds of the time were working tirelessly to invent the next big thing in electronics, and what they came up with would change the world forever. Enter our heroes, William Shockley, John Bardeen, and Walter Brattain. These three men were not just ordinary scientists. They were pioneers, visionaries, and relentless pursuers of innovation. Each brought a unique skill set to the table, making their collaboration a perfect blend of theoretical knowledge and practical application. These brilliant minds at Bell Labs were on a mission to replace those clunky vacuum tubes. Vacuum tubes were the backbone of early electronics, but they were bulky, unreliable, and consumed a lot of power. The team knew there had to be a better way, a more efficient solution that could revolutionize the world of electronics. They experimented with a strange new material called a semiconductor. Not quite a conductor, not quite an insulator, kind of like a chameleon of the electrical world. Semiconductors had the potential to control electrical current in ways that were previously unimaginable, opening up a whole new realm of possibilities. Now, Shockley, the visionary of the group, had an idea for something called a field effect transistor. This device, he believed, could amplify electrical signals and serve as a switch, all in a much smaller and more efficient package than the vacuum tubes. But his initial attempts were, let's say, less than successful. The field effect transistor concept was brilliant, but the practical execution was fraught with challenges. Materials didn't behave as expected, and the early prototypes failed to deliver the desired results. Good thing he had Bardeen and Brattain, the dynamic duo of experimentation, on his team. Bardeen with his deep understanding of quantum mechanics, and Brattain with his hands-on experimental skills, complemented Shockley's theoretical prowess perfectly. They say teamwork makes the dream work, and boy, did it ever. The trio worked tirelessly, bounding ideas off each other, testing hypotheses, and refining their approach. Their combined efforts and relentless determination were the key to overcoming the obstacles they faced. After weeks of tireless work, countless cups of coffee, and maybe a few head-scratching moments, they struck gold. The late nights and intense brainstorming sessions finally paid off as they began to see promising results from their experiments. On December 16, 1947, the first point contact transistor was born. This tiny device, no bigger than a paperclip, marked the dawn of a new era in electronics. It was more reliable, efficient, and scalable than anything that had come before, setting the stage for the technological revolution that would follow. So, what exactly is a transistor? It's a fundamental building block of modern electronics, found in everything from your smartphone to the most advanced supercomputers. Without transistors, our world would look very different. Think of it as a tiny gatekeeper for electricity. This gatekeeper can control whether electricity flows through a circuit or not, making it essential for switching and amplification. It can control the flow of electrons, switching it on and off, or even amplifying it, like a volume knob for electricity. Imagine being able to turn up the volume on your favorite song. That's what a transistor does for electrical signals. Here's how it works. A transistor is made of a semiconductor material with three regions: the emitter, the base, and the collector. These regions work together to control the flow of electrons. The emitter is like a pitcher throwing electrons towards the collector, which is like a catcher's mitt. The electrons travel through the base, which acts as a control gate. Now, the base is the real MVP here. It's the region that controls the entire process. By adjusting the voltage at the base, we can regulate the flow of electrons. By applying a small voltage to the base, we can control the flow of electrons between the emitter and collector. This small voltage acts like a key, unlocking the gate for electrons to pass through. A small voltage at the base can unleash a much larger current between the emitter and collector. That's amplification, folks. This principle is what allows transistors to be used in amplifiers, radios, and countless other devices. It's the magic behind the scenes that powers our modern world. Transistors come in different flavors, each with its own special abilities. There are bipolar junction transistors, BJTs, and field effect transistors, FETs. BJTs are like sensitive friends. A small change in the base current can lead to a big change in the collector current. They're great for amplification and switching. FETs, on the other hand, are more like independent thinkers. They use an electric field to control the current flow, making them super energy efficient. You'll find them in everything from smartphones to satellites. Section 5. Imagine a sprinkler system for electrons. Think of a transistor like a sprinkler system for electrons. The emitter is the water source, the collector is your thirsty lawn, and the base is the valve that controls the water flow. A small twist of the valve, which is the base, can turn a trickle into a torrent, or completely shut off the water supply. That's the power of a transistor. It gives us precise control over the flow of electrons, allowing us to create all sorts of amazing electronic devices. Section 6. From bulky boxes to pocket powerhouses. The invention of the transistor was a game changer. It revolutionized electronics and paved the way for the digital age we live in today. Remember those bulky, power-hungry vacuum tubes? Transistors sent them packing. These tiny wonders were smaller, faster, more reliable, and used way less power. This meant we could cram more computing power into smaller and smaller devices. Suddenly, radios shrunk from furniture-sized boxes to something you could hold in your hand. Computers, once behemoths that filled entire rooms, became compact enough to fit on a desk and eventually in your pocket. Section 7. The Microchip Miracle. But the story doesn't end there. The real magic happened when engineers figured out how to combine thousands, then millions, and eventually billions of transistors onto a single chip of silicon. Enter the integrated circuit, better known as the microchip. These microchips became the brains of everything from calculators and digital watches to spaceships and self-driving cars. And it all started with the humble transistor. Section 8. Transistors, the heart of the future. Today, transistors are everywhere. They're the beating heart of our smartphones, laptops, gaming consoles, and countless other devices. And they're only getting smaller, faster, and more powerful. Scientists are pushing the boundaries of physics to create even tinier transistors, just a few atoms wide. These nanotechnological marvels could revolutionize everything from medicine to energy production. Section 9. Tiny but mighty. So next time you're scrolling through your phone or watching a movie on your laptop, take a moment to appreciate the tiny giants that make it all possible. Transistors, despite their minuscule size, have had a colossal impact on our world. And as technology continues to evolve, one thing is certain: these tiny titans will continue to shape the future.